Alright, so today is the last day of September. 9:30. There we go. Jordan, can you turn off the lights, please? So 9:30:19. This bums me out. It always bums me out when the last day of September is not, or the last day of a month is not the 31st. Ask me why. It's a great question, because if it's the 31st, that means you can go to Baskin Robbins and get a scoop of ice cream for 31 cents. Did you guys know that? Yeah, it's true. So any month that has the 31st in it, on that particular day, you go to Baskin Robbins and you get a scoop of ice cream for 31 cents. But only on the 31st. Hi. You're in the back over there by Ananda. Okay? All right, so here's what we're going to learn about today. Medians. Centroids. Altitudes. And orthocenters. Okay? Julian, you're right there in group 1. Permanent seat. Okay, guys? So if today you woke up going, oh man, I hope today's the day I finally learned what a centroid is. Today is your day. It's going to be exciting stuff. Same with an orthocenter, okay? That first word, median, you guys have all heard that word before. You did it last year. Okay, you're right next to Dakota, so just pull that chair over there, okay? All right, and we'll get into these in, we'll talk about a median. You guys should remember what that word means, but just to quickly review, and we'll talk about it more in depth. But what is a median? What did you learn a median was last year?
I forgot.
It was not I forgot. Median meant it was a number where?
In the middle.
In the middle. Okay? So median is in the middle. That's how you know something's a median. Okay? But we're not going to talk about numbers today. We're dealing with triangles today. So you're going to learn what a median is in a triangle. You're going to learn what a centroid is in a triangle, what an altitude and an orthocenter are in triangles. Okay? All right. So let's just dive right into this. What do you guys say? So if you were paying any attention at all, what type of shape do you think I'm going to start off with?
Triangle.
Man, you guys are awesome. Okay, but let's start off with a median. So let's go ahead and do this, and let's talk about what a median is. And this is where the English language drives people loco. Crazy. Last year you learned that a median was a number in the middle. But this year you're going to learn that median has a totally different meaning than the number in the middle. And this is what drives people crazy about the English language, because the same word has different meanings. What's that called? Is that called an antonym? Or no, synonym is two words that have the same meaning. But what's it with the same word but it has two different meanings?
Oh.
Is that an antonym? Hominin? Whatever, who cares, right? That's English. Stupid. So, a median is a line segment. So I'm going to give you a definition, then we're going to draw one. So it's a line segment that starts at a vertex of a shape and ends in the middle of the opposite side. Okay, so let's see if I spelt everything right, left out any words. A median is a line segment that starts at a vertex of a shape and ends in the middle of the opposite side. Okay, so there we go. All right. Everybody know what I mean by the word vertex?
Yes.
What do I mean by that? It's a fancy way for saying the what of a shape. Right, the angle, the corner of the shape. So if you want to, you could put in parentheses under vertex the word corner, because that's what vertex means. It means go to the corner of a shape. Okay? All right, so let's start with the triangle, and we're dealing with triangles in this particular chapter. So we're going to talk about how do you make a median for a triangle. So go ahead and make yourself a triangle. If you have a straight edge, you could make it straight and make it look nice and neat. If you don't have a straight edge, then don't worry about it. Just kind of freehand sketch it out and make it look all not nice and neat. Okay, so we're going to have that. All right, so let's see. Let's call the bottom left vertex L for left. The bottom right vertex R for right. And the vertex at the top, we'll call that T, for it's at the top. Okay? And what we're going to do is we're going to draw a median. Okay? And so I don't care which corner I start at. Which corner do you guys want to start at?
R.
Let's start at R. Okay? So I'm going to draw a median from point R. Okay? So how do I do this? I'm going to make a line segment that starts at this vertex. So that's the vertex. That's the corner of the shape. It's going to start there at R, and it's going to end in the middle of the opposite side. Okay, so what side, if I start at R, what side would you guys think is considered opposite of R? Like, give me the two-letter side. LT. Nice. Side LT is the side that's considered the opposite of the vertex R. Okay? Some people say this, they go, Mr. Trutna, why don't you just say it's the side across from the corner? And it is. Okay, so notice, side LT is across the triangle from the corner that I'm starting at. Alright? It's the opposite side. So I'm going to make a median, I start here in the vertex. I'm going to go to this side, but I have to go right to the middle. Okay, so I'm going to put a point right in the middle. I'm going to make these tick marks right here to show that those points are in the middle. Miss James, nice to see you. Hey, right there. Thank you so much for being here today. All right, and then I'm just going to draw a line segment from R to the middle, just like that. Okay, you guys, that's a median. All right, and I'll write that in. Median, M-E-D-I-A-N. All right, why is it a median? Because it's a line segment that starts at the vertex of a shape and it goes to the opposite side of the shape, right to the middle. Okay, so that would be a median right there. All right, how many medians do you think I could draw in a triangle? Three. Because if I always start at a vertex, a corner, a triangle has three corners, therefore I could draw three medians. All right, so I'm going to grab another color, and now I'm going to go to another vertex. Which vertex do you want me to go to, L or T? Okay, so I'm going to start at T, and I'm going to draw a line segment going to the middle of the opposite side from T. Now, what side of the triangle is opposite of T?
LR.
LR. See, I'm color coding this for you guys so you could see it. Okay? And then I'm going to put a point right in the middle between L and R. I'm going to put the congruent marks to show that I have congruent segments. So that means I know that that point is in the middle. It's called the midpoint. And then I'm going to draw a line segment from T to the middle of the opposite side like that. Okay? So that would be another median right there. So that is also a median. And then I'm going to do it a third time. And the third time is easy to do. And the reason why the third time is easy to do is because what point am I going to start at to draw my third median? L. And then all I have to do, you guys, is start at L and now draw the line segment so it goes right through where the first two medians intersected at. So draw your third one so it goes right through the same place the first two medians intersected at, and lo and behold, you'll end it at the opposite side, and that point where you ended at will have to be in the middle. Okay? So this is an example of three medians being drawn inside of a triangle. And if you notice, the three medians all meet at one particular point. Okay? And that particular point has a weird name to it. It's not the center of the triangle. It's close to the center, but it's not the dead center. The dead center is probably actually about right where my pen is. So it's pretty dang close. All right? It's called the centroid. So this weird name, centroid, is where the three medians all meet. Okay? So what's the centroid? It is the, and does anybody remember the fancy way to say where three things meet? Point of concurrency. The point of concurrency. That's the fancy way for saying where three things meet. So the centroid is the point of concurrency where the three medians meet. Medians meet. All right? Boom, centroid right there. Point of concurrency, remember point of concurrency, just a fancy way to say where three or more things meet. In this case, it's three medians. All right? This weekend, I met some buddies at the movie theater. We were going to go see that one movie about that one thing. You guys know what I'm talking about, right?
Joker.
Yeah, no, not the Joker. Peanut Butter Falcon. And they go, hey, where should we meet before we go in? And of course, because I'm a nerd, I go, oh, you want to know where our point of concurrency is going to be? They disinvited me. Not funny. Sad. Gosh. No, I'm kidding. They didn't disinvite me. They're used to my nerddom. They appreciate my nerddom. They especially like me when they have to figure out how much a tip is. You know, like the bill's $100. Oh, we should give a 20% tip. How much is that? Yeah, 20% of 100. It's like, I don't know, $8.14. Something like that, right? No, it's $20, you knuckleheads. Okay, moving on. Altitude. Replace the L with a T, and that's something that a lot of you guys have in this class. Yeah, delayed reaction. It only took like 6 seconds for somebody to go, what? Oh, I get it there. Altitude. Okay, we've talked about this. Remember last week when we talked about the airplane? The altitude is what? Like if you're flying in an airplane and the pilot comes on and says, we are flying at an altitude of 12,000 feet. What's the pilot telling you?
How far you are.
Right, how high you are up from the ground. It's how far you are from the ground. And if he says, we completely lost power, we're going to crash. We fall 1,000 feet every 10 seconds. And you're at 12,000 feet. You're all, I got 120 seconds to live. Or to jump out of the plane. One of the two, you know, so then you could do the math there. So, an altitude is a line segment. Okay? So, you guys, it's going to be a line segment. So, that means it's going to have a starting point and a stopping point. Although both, remember, in a line segment, the starting and stopping point are called endpoints, okay? So, it's going to be a line segment that starts at a vertex of a shape of a shape. Okay, so it's just like a median in that regard. It's going to start at a vertex. Remember, vertex means the corner of a shape. A line segment, it starts at a vertex of a shape and ends when it is perpendicular to the opposite side. All right, to the opposite side. So notice in this one, as you're writing, I'll talk. Notice in an altitude, it starts at a vertex, a corner of the shape, just like a median, but it doesn't go to the middle of the opposite side. It doesn't end in the middle. It ends when it is perpendicular. Okay? And if you guys forgot, what's the mathematical symbol for the word perpendicular? Right, the upside down capital T. So I could have put that symbol instead of writing the word. And then once again, I'm going to go over here. And even though at the beginning of the class we discussed it on the board, I'm just going to draw a picture of two line segments that would be perpendicular with one another. So perpendicular means that right where the two line segments intersect, what has to be made? What type of angle has to be made? A right angle. Okay, that's what perpendicular means right there. Okay, two lines has to intersect to make a right angle. All right, so I need a shape. Take a wild guess. What type of shape do you think I'm going to make? A triangle. All right, last period somebody said a circle. Anybody see what problem? Anybody see why I can't have an altitude in a circle? Right, there's no vertexes, there's no corners in a circle. So you can't have an altitude in a circle here. So I'm going to start with the triangle. Alright, I'm going to name the bottom left vertex L, the bottom right vertex R, the top vertex T. Okay, and then what I'm going to do is I'm going to draw an altitude. And the easiest one to draw, the easiest altitude to draw is always starting from the top first. So let's start at T, the top vertex. So let's start right there. Okay, so how do I make an altitude? I have to draw a line segment. It's going to start at T. Okay, so it's going to start at a vertex, and it's going to end when it gets perpendicular to the opposite side. So what side is perpendicular from T? Speak up. LR, thank you. One person knew that. It's awesome. Better than 0. Okay, yeah, that's LR. That's opposite of T. Okay, and then how would I draw an altitude? This one's really easy. Straight down. Just draw it straight down. Put the 90-degree angle mark. That's an altitude. Right there. A-L-T-I-T-U-D-E. Okay? The other two altitudes are hard to draw. Harder. Not that hard, but harder. Okay, notice I said the other two altitudes. You could draw 3 altitudes in a triangle. Why can you draw 3 altitudes in a triangle? Where does an altitude start at? A vertex. How many vertexes are there in a triangle? 3. So that means I could start at 3 different places. Let's start at R now. Let's go down to the vertex R. Okay? What side is opposite of R? LT or TL. Okay? So now this one, we gotta be a little bit careful on how we draw this. So I'm going to start my line segment at R, and I'm going to use my ruler, and I have to draw the line segment, and I'm going to end it when it's perpendicular to side LT. So see how my ruler's set up right now, you guys? Does that look perpendicular to you? No. And remember how you check? You get out a piece of paper, and remember the corner of a piece of paper makes 90 degrees, and you can see I'm not at 90 degrees. So I need to, which way do I need to push my ruler, up or down? Okay, tell me when to stop. Once it appears that it is perpendicular, stop.
A little bit down.
A little bit down.
Yeah.
Let's see.
A little bit up, a little bit up.
Nope, I'm still off. Up, 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 up.
Never mind.
Boom. Look at that. Perfect. The corner doesn't lie of the paper. The corner of papers are always 90 degrees. Alright, so I'm a little bit like not clear because I got something in my mouth right now. Just spit it out, that was gross. Okay, alright, there we go. Perpendicular. 90 degrees. Made the 90-degree angle. That's an altitude. So we have two altitudes. Alright, the third one is easy to draw. And the reason why the third one's much more clear how to draw it. So the only vertex we haven't started at is L. Okay, now this one, you guys, to draw it, guess what it goes through? Right, it goes through the same place where the first two altitudes went through, where the first two altitudes intersected. So all you got to do is start at L, draw a line segment that goes right through where the first two altitudes intersected, stop it on the opposite side, and it would have to be 90 degrees. It has to be. It mathematically works out that way every single time. So I have three altitudes right here, and if you notice, the three altitudes all intersect at a point of concurrency. And that point has a weird name to it. It's a special center of the triangle. It is not, I mean, you can tell this one's not in the center of the triangle. So this one's called an orthocenter. All right, an orthocenter there. So what's an orthocenter? It is the point of concurrency. Of concurrency, where three altitudes meet. Okay? And that's all you need to know about an orthocenter in this class. If you go to college, when you go to college, if any of you become an engineering major, or like an architectural design major, you will learn about 7 rules about an orthocenter, other than how to make it. This class, all you got to know is that an orthocenter is made where 3 altitudes meet in a triangle. Okay, that's it.